Hi, year 11s and 12s. Today we're going to be continuing on in the cycle of aerobic respiration, or cell respiration. And this is Unit 8.2, HL topic from biology in metabolism, cell respiration, photosynthesis. This video we're looking at the Krebs cycle, so we've gone glycolysis to link reaction to now Krebs cycle. As I've said in the previous videos, no need to know in this video. If you want to look at the need to know for this topic, you need to go to the PowerPoint that's on the OneDrive. Let's begin. So the Krebs cycle itself, I'll just move the camera out of the way. In the Krebs cycle, this is the second stage of aerobic respiration, and it occurs within the matrix of the mitochondria. It's also commonly referred to as the citric acid cycle. So some people say Krebs cycle, some people say citric acid cycle. In the Krebs cycle, there's 2 more decarboxylation reactions and there's 4 more oxidation reactions. We start off this entire cycle with acetyl coenzyme A transferring its acetyl group to an oxaloacetate to make a citric acid. Coenzyme A is then returned to the link reaction so it can form another molecule of acetyl coenzyme A. Now, over a series of reactions, which we'll look at on the next slide when we look at a picture of the Krebs cycle, the citric acid is broken down to reform the original 4-carbon molecule. So oxaloacetate is a 4-carbon molecule. When we add the acetyl group, we make another 6-carbon molecule. And over a series of Krebs cycle, that citric acid, the 6-carbon molecule, is broken back down to the original 4-carbon molecule, which is why we call it a cycle, because it continues around and around. Across the entire Krebs cycle, we have multiple oxidation reactions. All of these reactions are resulting in the reduction of hydrogen carriers. So we're ending up with 3 lots of NADH and 1 lot of FADH2. We're producing 1 molecule of ATP through substrate level phosphorylation. And because the link reaction produces 2 molecules of acetyl-CoA, or coenzyme A, the Krebs cycle will also occur twice for each molecule of glucose. So for every molecule of glucose, we're creating, through the Krebs cycle, 4 lots of carbon dioxide, 2 lots of ATP, 6 lots of NADH, and 2 lots of FADH2. So having a look specifically at the Krebs cycle, okay, so we have our coenzyme acetyl-CoA coming along, the acetyl group's being transformed into our 4-carbon compound oxaloacetate, making our 6-carbon compound. As we're moving along, we lose a carbon dioxide molecule, creating a 5-carbon compound. We're also going through an oxidation reaction, forming NADH. From our 5-compound product, we're losing yet another carbon dioxide, or another carbon molecule, which becomes carbon dioxide, going through yet another oxidation reaction, creating another molecule of NADH. And we're also having our substrate level phosphorylation occurring here, which is going to create our molecule of ATP. All of this producing our original 4-carbon compound. We're going through 2 more oxidations, one to create FADH2, another to create NADH, before we return back and the entire cycle completes itself with the next acetyl coenzyme A.